Welcome to The Explainer. Today, we're taking an epic cosmic road trip right through our own heavenly home, the Milky Way galaxy. We're going to explore its staggering scale, its chaotic heart, and ultimately its terrifying destiny. Buckle up because this journey is absolutely going to blow your mind.
Since the dawn of humanity, as we've gazed up at that shimmering band of stars stretching across the night sky, one massive, intriguing enigma has always stared right back at us. What is the Milky Way truly like? What's it actually made of? And where exactly do we fit into this gigantic structure? Astronomers have literally been baffled by these fundamental mysteries for centuries.
Okay, let's dive into this. Just think about the number 20 million. When you step outside, far, far away from city lights, you might be able to spot around 6,000 stars. But for every single star visible to your naked eye, there are 20 million stars in our galaxy that we absolutely cannot see. Most are hidden by thick cosmic dust, they're too dim, or they're just way too far away. It instantly gives you a sense of the unfathomable, mind-bending scale we're dealing with today. Section 1. Leaving the solar system. Pushing past the heliosphere. Right, so to venture out into deep space, we first have to pass through the heliosphere. This is a massive, protective magnetic bubble blown out by our sun's solar wind. And wow, we are incredibly lucky to have it. Think of it from a Goldilocks perspective. This invisible shield buffets against the harsh interstellar medium, literally keeping out deadly cosmic rays. Without this exact bubble protecting Earth as we hurtle through the galaxy, life as we know it would for sure have evolved entirely differently, or honestly, maybe not at all. Now, there's a brilliant way to see exactly where that protective bubble ends. When the solar wind hits interstellar space at a boundary called the termination shock, it abruptly slams the brakes, decelerating from over 370 miles per hour down to just 62 miles per hour. This sudden slowdown marks the actual edge of our system. And to put those immense cosmic distances into perspective, it took the Voyager 1 spacecraft over 30 years just to reach this boundary.
Moving on to our next section, our stellar neighborhood, the Alpha Centauri system.
Now that we've crossed over into interstellar space, we're pulling up to our closest cosmic neighbors, located about 4.37 light-years away. And what's super fascinating is that this isn't just one star, it's actually a triple star system. We've got Alpha Centauri A, which is a sun-like star, and B, which is a bit smaller. But the closest individual star to us is the third one, Proxima Centauri. It's a small, highly volatile red dwarf flare star. And orbiting this little red dwarf are at least 3 exoplanets. The real showstopper here is Proxima b. It's a rocky planet parked right in the habitable zone. It's likely tidally locked, meaning one side constantly faces its sun, creating this bizarre, alien world where liquid water could potentially exist on the permanent day side, or maybe right along the twilight edge. But how long would it actually take us to get there? Well, if we send a traditional probe like Voyager at its absolute top speed, we'd be waiting around 80,000 years. Yeah, no thanks. But check out this alternative. The proposed Breakthrough Starshot project is an absolute game changer. The idea is to send tiny, light-sail nanocrafts. By blasting these tiny probes with an astonishing 100 gigawatts of ground-based lasers, they could be accelerated to 20% the speed of light. At that insane speed, we could reach Alpha Centauri in just 22 years. Let's zoom way out now for our next section, the galactic architecture, mapping the Milky Way. We're looking at a barred spiral galaxy spanning a staggering 100,000 light-years, and it has a very specific anatomy. There's a dense central bulge, plus 2 massive major spiral arms extending from a central bar. Those are the Perseus and Scutum Centaurus arms. Then you have the minor arms like Sagittarius, Norma, and our very own Orion Cygnus arm. And once again, we really have to marvel at our luck here. We reside in the relatively quiet Orion Cygnus minor arm. We're safely tucked away from the crowded, chaotic major arms, where dense clusters of stars unleash deadly radiation that could literally sterilize any nearby planets. We basically live in a nice, quiet cosmic suburb. The absolutely crucial thing to remember is that everything in this massive structure is moving. Take this staggering number, 250 million. That represents a single cosmic year. That's how many Earth years it takes our sun to complete just one full rotation around the Milky Way. Think about that. Even though our solar system is hurtling through space at roughly 220 kilometers per second,
The galaxy is so mind-bogglingly huge that the sun has only made this trip about 18 to 20 times in its entire existence. Let's continue our journey inward into the next section, the heart of darkness, giants, and monsters. Things are about to get chaotic and extreme. Now, what's really interesting about this comparison is the pure, terrifying scale of what's out there near the galactic center. We're comparing our sun to UY Scuti, a hypergiant star. Its radius is 1,700 times larger than our sun. Literally, if you picked up UY Scuti and placed it exactly where our sun is, right now, its outer surface would extend all the way past the orbit of Jupiter. It would swallow Mercury, Venus, Earth, Mars, and Jupiter completely whole, just gone. But honestly, even that hypergiant pales in comparison to the true monster lurking at the very center of our galaxy, about 26,000 light-years from Earth. 4.3 million. That number represents the mass of Sagittarius A star, the supermassive black hole at the galactic core. It packs the mass of 4.3 million of our suns into a single, infinitesimal point, creating a gravitational singularity where space and time warp entirely beyond recognition. To truly grasp what this means, we have to look at a mind-bending phenomenon called frame dragging. You see, the black hole at the center of our galaxy isn't just sitting there peacefully. It's spinning at near its absolute maximum physical limit. And because a black hole is a region of space-time with no solid surface, as it spins, it literally distorts and drags the very fabric of reality along with it. It bends light into rings, it warps time, and it twists the surrounding space into an unimaginable cosmic whirlpool. It is an absolutely awe-inspiring phenomenon. But just when we thought we had this monster figured out, a huge scientific twist emerges. Could Sagittarius A star actually be a massive concentration of dark matter? Recently, a gas cloud known as G2 drifted perilously close to the center. Astronomers completely expected it to be ripped apart and devoured by the black hole. But instead, it survived. It kept right on drifting, almost totally intact. This major anomaly has led some scientists to theorize that the center of the Milky Way might not be a black hole at all, but rather a dense clump of dark matter particles masquerading as one. It's a hugely fascinating debate unfolding right now in the astronomical community. Okay, let's move to and see how this builds as we look ahead to the very end of our journey section, the ultimate cosmic collision, our galactic fate. You see, our galaxy grew to its massive size by acting like a cosmic predator, consuming other, smaller galaxies. First, we swallowed the Kraken galaxy about 11 billion years ago. Right now, as we speak, we're actively consuming the Canis Major Dwarf galaxy, literally tearing its stars away. But the grand finale? That's still yet to come. We are currently hurtling through space at 250,000 miles per hour on a direct, unavoidable collision course with our massive neighbor, the Andromeda galaxy. Let's walk through this future cosmic clock to see exactly how it all ends. In 4.5 billion years, the Milky Way and Andromeda will finally collide, kicking off a massive, beautiful merger. Now, because galaxies are mostly just vast stretches of empty space, the odds of another star physically crashing into our solar system during this merger are practically zero, so we'd survive the galactic collision. However, our real doom is much closer to home. Around the 4 billion year mark, a heating sun will trigger a runaway greenhouse effect right here on Earth. And by 7.5 billion years from now, our sun will expand into a massive red giant and finally swallow the Earth whole. It's a pretty heavy thought, I know, but it really brings a profound sense of cosmic humility. I want to leave you with this powerful, poetic conclusion from our source material that brilliantly captures our place in all of this. We are the very children of the universe, born from ordinary chemicals over billions of years, now gazing wondrously into the endless black abyss. It leaves us with one final awe-inspiring question to ponder. Are we just a fleeting, temporary spark in this giant galactic timeline? Or is this grand cosmic collision actually just the beginning of a brand new chapter for life in the universe? Thank you so much for joining me on this explainer. Keep looking up and never lose your sense of wonder.